morning, everybody. Welcome back. We're going to talk about the second day of 6.5 today, which we're going to talk about change of base formula so we can start evaluating any kind of logarithm. Okay, so first of all, let's look about applying logarithms and kind of a story problem. So the solution of the pH of a solution is a measure of its concentration of ions. This concentration is measured in moles per liter, is written in this hydrogen positive, and is given in this formula right here. So pH equals the logarithm of 1 over this hydrogen positive here. So just a little reminder here of what our log properties are. So what's the concentration of hydrogen ions in acid rainfall? So here our pH of our acid rainfall is 4.5. So just plug that pH over here into this pH value here. Okay, so let's go ahead and write that equation out. Get my little trusty pen here. It's all jingled up. So 4.5 is going to equal the log of 1 over my hydrogen plus. Okay, so I'm going to use my log properties here. So 4.5 equals, and the common example mistake up here, read that. So log of 1 minus log of hydrogen positive. Okay, and so log of 1, if you will recall, pull this up here, my log of 1 is anything to the 1 is 0 power, is 0. Okay, so that just becomes 0. So we have 4.5 equals a negative log of my hydrogen positive atoms. And I'm going to move this negative out of here. So I'm going to multiply both sides by -1, -1. Let's get rid of that negative. So we have negative 4.5 equals log of my hydrogen positive atoms. Now I'm going to go ahead and exponentiate this guy. Okay, so it's base 10. So I'm going to go 10 to negative 4.5 equals my hydrogen concentration, hydrogen positive. Okay, so now let's go ahead and stick it in here and see what happens. So we have 10 to the negative 4.5 here. Whoops, not 9, 4.5. And that's this exponent, so we got to move our decimal 5 places. So that's going to be so our hydrogen concentration is going to be 0.00003. What was that? 36, I believe. Yeah, 36 moles per liter, right? Moles per liter is what that was in. Okay, and so that's how you solve that. Just using your equation and exponentiation to solve. Okay. It says now what's the concentration of hydrogen ions in orange juice? Well, we just come over here and look at our orange juice, and this time it would be 3 equals all of this gobbledygook, log of 1 over hydrogen concentration. Okay, and I'll let you guys solve that if you'd like to do that. Okay. All right, so now we're going to look at change of base formula. So this is just for any positive numbers a, b, and c. B can't be equal to 1, c can't be equal to 1, etc. Our log base b of any number a, we can change the base to any base c. Okay, so we want to change it to base 10. Awesome. So we just change it to log base whatever of a over log base whatever over b. So we just take the log of a over log of b. You just have to memorize this, guys. Okay, log of a over log of b. It's simple. I just kind of remember it's just like this. Whoop, log of a over log of b. Okay, so it's basically log of, or natural log. So we're usually always changing to natural log or common log. Okay, and so let's take a look at how this works. So let's just change the base to all of these. So this is going to be just log of 11 over log of 3. Boom, done. Okay, this is going to be log of 3 over log of 7. Boom, done. Okay, log of 8 over log of 5. And now the nice thing is we can actually put those into our calculators and evaluate them. Okay, and so now let's actually see how it works here. So it says estimate the value of the logarithm, then use a calculator to find the actual value of it to the nearest thousandth. So if I were to actually estimate this, it's going to be 2 to some power equals 7. Well, we know 2 to the third power equals 8, right? So we're close to that. So it's got to be somewhere under 3. And so if I'm going to use a change of base, we're going to go log of 7 over log of 2. Okay, and that's going to be approximately equal to, so we're going to pour our calculator up here. And we're going to go log of 7 divided by my log of 2. And find out what that is. So it's just 2.807. So it's about 2.807. Okay, and that's the value of that log base 2 of 7. Okay, so how about this guy? Log base 5 of 3. So 5 to some power equals 3. So log to the first power equals 5. So it's got to be probably not just probably maybe not quite just under 1, but maybe a little bit more under 1, not quite 1/2. Okay. So let's see what we get here. So we got log of 3 divided by log of 5. And so we have, let's go log of 3 divided by log of 5. We've got 0.6826. 0.683. We're going to go to thousandths, so since it was 26, so 0.683. Okay? And there you go. So now we're going to start finding actually solutions. Okay? So what's a solution to this equation? 2 to the x power equals 7. So first let's write that down. So 2 to the x power equals 7. Write in logarithmic form. So I'm going to have log base 2 of 7 equals x, right? So now I can actually change the base here. So it's log base 7 over log base 2, or log base 10 of 7 over log of 2 equals x. And now we can actually evaluate that. Okay, so log of 7 divided by log of 2. That's going to give me about 0.2807. About 2.807. Now I can't remember what I was watching. 2.807. 2.807. Okay. So now just for funsies, I'm just going to show you a little bit of also what you can do. I'm not going to move that. If we have, I'm going to do this in a different color here. So 2 to the, gracious sakes. 2 to the x equals 7. You can also, if you take the log of both sides, because it's an operation, if I go like this log of 7, then you can actually use your properties and put x out over here. So x log 2 equals log 7. And then we just divide by log 2. So x equals log 7 over log 2. And that's what you end up having the same expression as that right there, right? And so there's a couple different ways you can do that, okay? All right, so let's keep using change of base. I just want to put that in the back of your head because our next unit will be looking at that a little bit deeper, okay? So how about this guy? What's the solution to this? 3 to the x equals 15. Let's take the log form. So log base 3 of 15 equals x. Okay, so log of 15 over log of 3 equals x. And so let's find out what that is. Log of 15 divided by log of 3 equals about 2.465. So 2.465, and there you go. It's the value of that log. Okay, that x. So now it's solved using natural logarithms. You can do the same thing with natural logarithms. So if I go 3 to the x equals 10, I can change the base. So first of all, I'm going to go, we'll go log, let's go log base 3 of 10 equals x. Okay, so this time I'm going to change the base to natural log. So I'm going to go natural log of 10 over natural log of 3 equals x. So I just changed the base to natural log base e instead of 10. And so now this time I'm just going to go natural log of 10 divided by natural log of 3. And we can do the same thing. Okay, 2.096. So about 2.096. Okay, so you can also change bases to natural logarithm as well. Okay. Okay, so that's a little summary of this unit, and you have an Excel and Google Classroom, and I will see you in class. Please bring your questions. Thanks so much. Bye-bye.